We're going to solve an equation using the echelon method. And I have 8x minus 7y equals negative 3. And the second equation is negative 16x plus 14y equals 6. So we're going to solve this by the echelon method. So the echelon method wants us to make that first, right there, that needs to be a 1x. So in order to do that, I could do multiply my row 1 by positive 1 over 8. So to get a new row 1, I'm going to multiply row 1 by 1/8. So what is that going to give me? Well, that's going to give me x minus 7 over 8y equals negative 3/8. And then my row 2 is still 16x plus 14y equals 6. Then the next step, according to the echelon, is to make that 0. Okay, so how can I get that second row to be 0, or my new row 2? So my new row 2, I'm going to multiply row 1 by 16 and then add it to row 2, and that'll give me my new row 2. So my first row is going to stay the same, and we're going to change our row 2. Okay, and let me move this over just a little bit, see if I can give us a little more space here. So my new row plus row 2. Okay, so 16 times row 1 would be 16 plus a negative 16, so that's going to be 0. And then 16 times row 1, well, that's going to be 8 goes into 16, that's going to be negative 14. Negative 14 plus 14y is going to be 0. And then 16 times negative 3/8 is going to be 2, and 8 goes in 16 twice, that's going to be negative 6. Negative 6 plus 6 is 0. So we end up with, my x minus 7/8y equals negative 3/8, and I end up with zeros all across the bottom. So what does that tell me as far as my system? Well, that tells me I'm going to have infinite solutions. But we need to write it in terms of our parameter. Our answer isn't just infinite solutions. We need to write it in terms of our variable, and our parameter here is going to be y. So y becomes our parameter. We have two variables, so y becomes the parameter, and I end up, so y can be any number, and then I need to solve x minus 7 over 8y equals negative 3/8 for x. So I'll add that 7/8y to both sides. So I'll end up with x equals 7/8y minus 3 over 8. And so 7y minus 3 over 8. So that would be my answer for this particular question.
Let's look at the same problem using a calculator. So I'm going to bring up my calculator, and I'm going to go to second matrix, and I'm going to put my matrix in, and this is already in, we have our x's, y's, and so it's in the proper form that we have. We just need to write it as an augmented matrix, and it would be a 2 by 3. So I would have 8, enter, negative 7, enter, and then negative 3, enter. So there's my first row. And then my second row would be negative 16, enter, 14, enter, 6, enter. So you want to double check, make sure you have everything in there correctly. And then we're going to go to second, quit, second, back to matrix, scroll over 1 to math, and we're going to go to RREF, enter, second matrix, and it was matrix A we put in, and we're going to enter. And so this is what we get. And we can convert these to fractions by hitting math and then enter, enter. and look at it a little bit, and you see we have zeros all the way across the bottom. So what does that tell me? Well, that tells me we're going to have an infinite number of solutions. However, we're going to have to write it in the form as far as y is going to be any real number, but then I need to take my x here, which is the first, so this would tell me x minus 7/8 y equals -3/8. So I need to write this in terms of y because y is my parameter, and so I'm going to have x equals 7/8 y minus 3/8. And so that's going to be x in terms of y, so that's why it would be an infinitely number of solutions, and the first spot, or what would go in this box, would be 7y minus 3 all over 8. And that just saves us some time from doing echelon form. The calculator does help a little bit as far as reducing a little time.